Hello, this is Mrs. Bentley, and I'm here to go over writing linear equations day 2. So yesterday we learned or reviewed how to write linear equations if we were given the slope and the y-intercept. We also looked at problems that were not written in slope-intercept form. Most of them were in standard form, and we reviewed how to solve for y and rewrite the equations in slope-intercept form. And the other way we looked at was the graph. So we talked about how we could look at the graph and we could count rise over run to find the slope. We can look to see where the line crosses the y-intercept, and then we can build the equation by filling the slope in for the variable m and the y-intercept in for the variable b. Today we're going to look at a new form that most of you have probably never seen, and that's called point slope form. And point slope form is good to use when you're given a point that the line passes through and the slope of the line. And you're going to start by substituting coordinates in for the x1 and the y1, and you're also going to substitute the slope in the place of m. So in point slope form, we're going to substitute a number in the place of y1, a number in the place of m, and a number in the place of x1. So the point is going to be your x1 and your y1 value, and the slope, m, is your m value. So in our first problem, we are going to say y minus, the formula is subtraction, so make sure you do y minus 7 equals the slope 3 times x minus 4. Now I know in calculus and some of your upper level mathematics they'll have you actually leave the equation in point slope form. But in Math 1 we use this form just to substitute in the point and the slope, and now we're going to use our equation solving steps to solve for y. So we're going to just keep the y minus 7. On the right side we're going to distribute the 3, so 3 times x simplifies to 3x. 3 times minus 4 simplifies to minus 12. And now to get our y by itself, we just need to add the 7 on both sides. And our opposite 7s equals 0, so the final equation in slope-intercept form is y equals 3x, negative 12 plus 7 simplifies to minus 5. So this line has a slope of 3 and a y-intercept of negative 5. Okay, let's look at a couple more examples. So again, the point is going to be your x1 and your y1 coordinate, and your slope is your m. So we're substituting into point slope. So y minus 6 equals negative 5 times, be careful here, we're saying x minus a negative 3. Now when you see that double negative, remember that's going to become plus a positive. So go ahead and change that to a plus sign. Okay, we're going to bring down the y minus 6 equals and distribute. Negative 5 times x is negative 5x. Negative 5 times positive 3 is minus 15. And now just one more step to solve for y. We need to add the constant, the 6, on both sides. So our opposite 6's cancel, and we're left with y equals negative 5x. And then negative 15 plus 6 is minus 9. So this line has a slope of negative 5 and a y-intercept of negative 9. Okay, for number 3, we have a point. The x-coordinate is negative 8 and the y-coordinate is negative 4. Our slope is 1/2. So again, we're going to say y minus the y-coordinate. Again, be careful, it's y minus negative 4, so this becomes y plus 4 equals 1/2 times x minus negative 8. So this is going to become x plus 8. Okay, we're going to just rewrite the y plus 4 equals, on the right side, distribute, so 1/2 times x simplifies to 1/2 x, and half of 8 simplifies to plus 4, and now we're going to subtract 4 on each side of the equation. 4 minus 4 is 0, 4 minus 4 is 0, so that means our y-intercept is 0, so we have a slope of 1/2, and you can stop there. So your equation is just y equals 1/2 x. If there's not a number in the place of b, then it's understood the line passes through the origin because the y-intercept is at 0. Okay, we're going to look at just 3 more examples. We need to review lines that have 0 slopes and lines that have no slope, undefined slopes. So if you think about a line that has a slope of 0, that's going to be a horizontal line. And horizontal lines pass through the y-axis. So the shortcut is that you only need to know the y-coordinate that the line passes through this point. So you would get the equation just y equals 15. Now let's say you didn't catch this shortcut. You didn't think about this, this equation being just the y equals 15. You could also say y minus 15 equals 0 times x minus 9, and you could still go through the solving process. So y minus 15 equals 0 times x, that's 0. 0 times negative 9 is also 0. So on the right side of the equation, we just have 0. And when we go to solve for y, we add 15 on both sides. So you will see that the equation simplifies 0 plus 15. So the equation is just y equals 15. This is always going to happen when you have a slope of 0. So when your line has a slope of 0, you only need to know the y-coordinate. Okay, for number 5, we're looking at another fraction. Again, we're going to have to distribute that fraction through, so hopefully it'll cancel out. So we're going to say this is our x1, our y1, and our slope is negative 1/3. So we're going to write this as y minus 2 equals negative 1/3 times x minus negative 9. So go ahead and change that to plus 9. We're going to keep the y minus 2, and on the right we need to distribute. So negative 1/3 times x is just negative 1/3 x. And a negative times a positive 9, remember that's going to be a negative, and 1/3 of 9. So that's like 9 divided by 3. So this simplifies to minus 3. Okay, to finish solving for y, we're going to add 2 on both sides of the equation. The negative and positive 2 will cancel out or equal 0, so we're left with y equals negative 1/3 x, and negative 3 plus 2 is minus 1. So our final answer is y equals negative 1/3 x minus 1. Okay, so in number 4 we talked about a line that had a slope of 0. Now we're looking at a line that has no slope. That's also the same thing as undefined slope. So a line that has an undefined slope is going to be a vertical line. And a vertical line intersects the x-axis. So to write this equation, since we know our line passes through the point 10, negative 7, we only need to know the x-coordinate of the given point. So the equation of the line is just x equals 10. Okay, we're going to look at a new type of problem. The last problems we were looking at, we were given a point and they told us the slope. Now they're only telling us the 2 points the line passes through. So remember, we know how to find slope given 2 points. So we're going to have to start with that step. So it says write an equation of the line that passes through each pair of points in slope-intercept form. So our step 1 is going to be to find the slope. And just to remind you, your slope formula, you're going to take the second y-coordinate, so y2 minus y1 over x2 minus x1. And then step 2, we will substitute one of our points. And the slope into our point slope form. So that's y minus y1 equals m times x minus x1. So we're still doing the same process we just did on those last examples. We're just going to have to add one extra step. So this time we're going to have to start by finding the slope. So the first point I'm going to label as my x1 coordinate and my y1 coordinate. My second ordered pair is my x2 coordinate and my y2 coordinate. Okay, so we're going to find our slope. We're going to take the second y coordinate, -4, and subtract the first y coordinate, 2, over -2 minus 4. -4 minus 2 simplifies to -6, and -2 minus 4 also simplifies to -6. -6 divided by -6 simplifies to a slope of 1. Now, we only need 1 point. We're given 2 points. So I recommend picking the point that looks the easiest. So I'm going to select 4, 2 as my point. So now I'm going to substitute those 3 numbers into my point slope form. So remember, this is my x1, my y1, and our slope is 1. So we're going to say y minus 2 equals 1 times x minus 4. We're going to keep our y minus 2 on the left, and on the right we're distributing the 1, so 1 times x is x, 1 times -4 is minus 4, and now to finish solving for y we're going to add 2 on both sides. Okay, and that's going to simplify to y equals x minus 2. So your final equation is y equals x minus 2. Okay, number 8, we're given the point 0.5 and the point -3.5. So the first thing we need to do is find the slope. So m equals 5 minus 5 divided by -3 minus 0. Well, 5 minus 5 equals 0, and -3 minus 0 equals -3. And when we simplify 0 divided by -3, the slope equals 0. And remember, a line that has a slope of 0 is a horizontal line. A horizontal line intersects the y-axis. So we only need to know the y-coordinates. And if you notice, both points have the same y-coordinates. Y-coordinate of 5 and a y-coordinate of 5. So our equation is y equals 5. So what I suggest is always look at your 2 points. If the y-coordinates are the same, then your equation will just be y equals that number. If your x-coordinates are the same, that's going to be a vertical line, so your equation will be x equals the x-coordinate. So I'm going to test that out with number 9. If I look at number 9, I have an x-coordinate of 2 and an x-coordinate of 3, so those are not the same. I have an x-coordinate of a y-coordinate of -2 and a y-coordinate of +2. So those are not the same. So this line is not going to be horizontal or vertical. So we need to do the entire process. So we're going to start by saying the slope equals y2, so 2 minus -2, so that becomes 2 plus 2, divided by 3 minus 2. And if we simplify, 2 plus 2 is 4, 3 minus 2 is 1, and we can simplify our slope to 4. I'm going to use the second point this time, the 3, 2. And now we're going to substitute into point slope form. So y minus our y-coordinate 2 equals the slope times x minus the x-coordinate, and that is a 3. So keep your y minus 2 on the left, distribute your 4, so 4 times x, 4x, 4 times the -3 minus 12. And now we need to finish solving for y to get it into slope-intercept form. So we're going to add 2 on both sides of the equation. So we get y equals 4x. -12 plus 2 is -10, so minus 10. So your final equation in slope-intercept form is y equals 4x minus 10. This line has a slope of 4. It has a y-intercept of negative 10. Okay, I would like for you to take a few minutes and try 10, 11, and 12 on your own. So pause the video, work those three out, and then once you're finished, you can start the video back and you'll be able to check your answers with mine. Okay, so you should have had some time to work those out on your own. So if you look at your work, check your answers with mine. For number 10, you should have found the slope was 3, and I used the point 12.2, and you would find the equation is y equals 3x minus 34. Number 11, I didn't check for my 2 points to see if my x coordinates or y coordinates were the same, so I found the slope. And when I saw that 0, I knew I had an undefined slope, because remember, we can never divide by 0. If you're ever unsure, you can type this in the calculator, -7 divided by 0, and it will give you an error message, which means the slope is undefined. And when we have a slope that's undefined, we have a vertical line, and vertical lines will always intersect the x-axis. So I looked back at my 2 ordered pairs and I noticed that my x coordinates were both -5. So the equation can only be written as x equals -5. For number 12, I found the slope was -1 and I used the point 0.86. I substituted that information into point slope form and I got the equation y equals x minus 2. Okay, one more type of problem in today's lesson. It says, given the x and y intercepts, write the equation of the line in slope-intercept form. So they're telling us that the line has an x-intercept of -3 and a y-intercept of +5. So first of all, let me just kind of give you a visual of this. So I'm going to draw a quick little coordinate plane. So an x-intercept is just a point where the line crosses the x-axis. So on the x-axis, our line is intersecting at -3. So there is a point on the x-axis at -3. Now what I want you to think about is, what is this ordered pair? We start from the origin and we go left 3 and we don't go up or down. This ordered pair is the ordered pair -3, 0. So I want to point out something. All x-intercepts can be written as an ordered pair. The y-coordinate will always be 0. Now let's look at the y-intercept. The line crosses the y-axis at +5. So 1, 2, 3, 4, 5. So here's our y-intercept. So now I can actually sketch the line. So here's our line. And if you think about this ordered pair, we said this ordered pair was located at -3, 0. This ordered pair, we're not moving on the x-axis, we're staying at the origin. So our x-coordinate is 0, but on the y-axis we're going up 5. So this point is at 0, 5. So all y-intercepts will have an x-coordinate of 0. So notice this 5 became the y-coordinate. This -3 became the x-coordinate. Now remember what it takes to write an equation in slope-intercept form. The two numbers we need to know are our slope m and our y-intercept b. Notice in this equation they are telling us that our y-intercept equals 5. So we know that the b value is 5 in the equation. The only thing that's missing is our slope. Now since I've drawn a picture of my graph, I could actually count my rise over run. I'm going up 1, 2, 3, 4, 5, and I'm going right 1, 2, 3. So the slope of this line is 5 over 3, and now I can form the equation y equals 5 third x plus 5. Now, you may not want to draw the graph each time, so the other option would be to take the 2 ordered pairs that we formed and we could use our slope formula. So we could say our slope equals our second y-coordinate 5 minus our first y-coordinate 0 over our second x-coordinate 0 minus -3. And again, that becomes plus 3. So on top we have 5 minus 0. This simplifies to 5. And 0 plus 3 simplifies to 3. So we can also see our slope is 5 over 3. So you could draw the graph and count rise over run, or you could form your two ordered pairs and use your slope formula. Okay, so in example 13, they tell us the x-intercept is 6. So we know as an ordered pair, this would be 6, 0. And our y-intercept is 3, so this would be the ordered pair 0, 3. We also know our y-intercept, so in the equation, that's also the value for b. So b equals 3. So now we just need to find our slope. I'm going to use the formula this time. So if this is my x1, y1, x2, y2, we're going to say 3 minus 0 over 0 minus 6. And now we're going to simplify. So 3 minus 0 is 3, and 0 minus 6 is 6, and we would reduce this to 1/2. So now we know our y-intercept is 3, we know our slope is 1/2, so the equation of the line is y equals 1/2 x plus 3. Thank you, and this has been Mrs. Bentley with Writing Linear Equations, Day 2, given a point and slope and given 2 points. And we also looked at a couple of examples with the x and y-intercepts. Okay, so if you flip over to the back, you're going to see the student practice 1 through 14, same layout as my guided notes. So that is your assignment for this lesson.